Hi everyone, this is Mrs. Musoff here. Today we are going to talk about how to solve radical equations. So our goal is to solve equations that have radicals in them and also to check for extraneous solutions. Okay, so before we talk about extraneous solutions, let's just make sure you remember how to go about solving. At any time we're solving an equation, the order we use is always reverse PEMDAS. So that means we do addition and subtraction first, multiplication and division, any exponents, or radicals. So radicals count as an exponent like we saw in last unit. Radical can be written as an exponent, so they are the same idea. And so radicals or exponents would come next, and then any parentheses. Alright, so for the purposes of our equations, another way to think of it is we're always going to get rid of the operations outside of the radical first, and typically that'll be your addition, subtraction, your multiplication, division. We're going to get rid of the radical, and that's like the exponent step here. And to get rid of a radical, we actually use an exponent because radicals and exponents are inverses, or opposites, right, like addition and subtraction. And then the last step is going to be to get rid of any operations that were inside the radical. And sometimes you'll have operations inside the radical, like in number 2 down here, and sometimes you won't. So that step 3 is when necessary. All right. For these examples, we're going to solve for x, and we're going to check for extraneous solutions. Now, just a reminder, I'm not sure if we've talked about this before or not, but extraneous solutions are solutions that you get correctly when you're solving, but when you substitute them back into the equation, they don't give you a true statement anymore. So they're solutions that are actually invalid after you double check yourself. So in order to check for extraneous solutions, we're going to substitute the answer back in. Alright, and you can do that by hand or you can do that in the calculator. I'll show you both just so that you can get an idea for which you prefer. Alright, so let's try a few examples. Alright, so like I said, we're going to solve for x, we're going to check for extraneous solutions. In number 1, we have the cubed root of x plus 3 equals 5. So if you follow the steps we have up here, the first thing we want to do is get rid of operations outside the radical. That means any addition, subtraction, multiplication, or division that's not underneath this bar, right? That's what we want to get rid of first. So the plus 3 is not underneath the bar. That means it's outside. So I'm going to subtract 3 and get rid of it first. Okay. If I subtract 3 from the left side, that means the 3 is gone. So I'm just left with the cubed root of x, and on the other side 5 minus 3, that's going to give me 2. Okay, now if there were other things on the outside of the radical, we would get rid of them now also, but since there's nothing left, that means the next step is to get rid of the radical. Okay, this is the new part, right? We've never solved a radical equation, so you've never had to get rid of a radical before. But what we're going to learn today is in order to get rid of a radical, we use an exponent, specifically the same exponent as the radical you have. So for example, in this problem, it's a cubed root, a third root. So to get rid of a third root, we raise both sides to the third exponent. And notice how I'm using parentheses here. That's because you have to raise the entire side to the third exponent. So if there was, say, a negative in there, right, it's a negative 2, that whole thing would be being raised to the third. Okay. On the left side, what should happen is a third exponent and a third root. They just cancel each other out. So here I'm just left with an x. And on the other side, 2 to the third, I could do that by hand, right? That's 2 times 2 times 2, which should give me 8. And so since there's nothing left to do on the left side, it just says x equals, that means I'm done solving. But before I circle this answer, I am going to check for extraneous solutions. So off to the side here, I'm just going to write check, and I'm going to show my work for how to check my answer. Every time you need to check for extraneous solutions, you have to at least show a step or two that you did check. So you can use your calculator to help you out, but we still need to see the work that you checked your answer. Alright, and to check, like I said, we're going to take this answer here, x equals 8, and we're going to substitute it back into the original equation. So that would be the cubed root of 8 and then plus 3. What we want to know is, does that equal 5? So I'm going to put a little question mark here because that's what I'm checking. Alright, now the cubed root of 8, hopefully we're starting to get more familiar with our perfect cubes. The cubed root of 8 is just 2. So I'm really left with 2 plus 3 equals 5. And is that true? Yes, it is. So that means x equals 8 is a correct answer. Alright, now if I wanted to check it on my calculator, I'll show you how we can do that real quick. It's pretty simple. I'm sure you remember. To get a cubed root, on my calculator, I'm going to press math, and then it's number 4 right here, cubed root. And so I'm going to type in the cubed root of 8, and then I'm going to move outside of the radical. I'm going to type in plus 3. And what I'm checking is, does that answer give me 5, like it's supposed to? And since it does, I know I did it right. Okay. Alright, let's try another one, a slightly more complicated one. Make sure we're understanding it. Alright, number 2, 4 times the square root of x plus 1 minus 3 equals negative 23. So again, anything that's not underneath this bar is what I'm getting rid of first. So that would be this 4 and this minus 3. Now this is a times 4, whereas this is a minus 3. And if you remember what we mentioned up above, we go in reverse PEMDAS. That means we actually want to get rid of addition and subtraction first. So the minus 3 is the part we're going to get rid of first. So I'm going to add 3 to both sides. That'll leave me with 4 times the square root of x plus 1. And on the other side, negative 23 plus 3 is negative 20. Okay, and now I still need to get rid of that times 4, so to do that I'm going to divide by 4. All right, get rid of everything outside of the radical first. And that's going to leave me with the square root of x plus 1, and now negative 20 divided by 4 is negative 5. Okay. Now, since I'm done with everything outside the radical, the next thing is to get rid of the radical. Do you remember what kind of radical it is when there's no number there? Hopefully you heard me saying it. It's a square root. Right? When we think of square, like a number squared, right, that means it's raised to the second. So a square root is actually a second root. And that means to get rid of it, I'm going to raise both sides to the second power. Okay, notice how I put parentheses around the whole number, the entire negative 5. That makes a difference when it's a negative number. All right. So over here, square root and square exponent get rid of each other. So I'm just left with x plus 1. And on the other side, negative 5 squared, remember that's like doing negative 5 times negative 5. And a negative times a negative is a positive, so that would be positive 25. And all I have to do to finish solving is get rid of this plus 1. That's the part that's inside the radical, right? We always save it for last. So minus 1 on both sides. And I'll end up with my answer of x equals 24. But again, remember, before we say, awesome, done, all right, circle it, move on, we always have to check our answers. So I'm going to just write it down right under here, check it, and to check, I'm just going to plug it back into the equation. So 4